Hello everyone, and welcome to the 100th episode of Fabrics of the Cosmos, spectacular space science with special scenes. Alright guys, today is a very special episode. We have a guest star here. I'm not going to tell you who she is yet because it's that exciting. Wait a minute. This episode was supposed to be about something, but I literally forgot what it was. I brushed my teeth today.
I fed my pet eagle.
What? What are we missing? Cut the camera real fast.
A few moments later.
This is embarrassing. I'm sorry I brought you here. There was a reason. There's something we were gonna do before we got to the special part. Wait. Usually I have someone with me when I do these videos, don't I?
No?
I don't.
Yeah, you do.
I do.
Yeah.
Oh. Well, we gotta go find her then. Okay. We're at Brielle's house. I bet she's here. You go ahead and knock. She doesn't answer to me anymore. Brielle.
Not here. At this moment, we are looking for Brielle so she can explain the physics to us. But we can't find. The centrifugal force is insane.
Actually, it's centripetal force. No. Wait.
Pick the other one.
Not in there either. And here lies Brielle.
Brielle's not even dead. I saw her at the track.
Really?
Yeah.
She's not anywhere ugly.
Why can't you trust an atom?
Why?
They make up everything. I see her! I see Brielle! Brielle, where have you been? I've been looking for you everywhere.
Hello, Oakley. Why are you here? I was just going for a little jog.
To film a video, of course.
Oh my gosh, I forgot about a video! But, while we're here, this is a perfect time to introduce our next concept. Did you know that each time I take a step, I'm counteracting Earth's gravity? And we know through past physicists and mathematicians that acceleration due to gravity is actually 9.8 meters per second. And each time I take a step, I have to counteract that to be able to move. And we call this work. And we have been able to come up with formulas to be able to calculate the amount of work I'm doing. Do you want to see this in action?
Yeah.
Well, then it's off to the weight room.
Okay, so we're here in the weight room, and what we're gonna do is we gotta see how much work Brielle is putting into her weightlifting. So the equation for work is force times distance, and in order to find a force, we need to find the mass and the acceleration. So that's what we're gonna do. We're gonna find the mass of her weight, and then we're gonna find the acceleration. In order to do that, we need to find how many meters and how long and how many seconds, because meters per second squared is the acceleration. And then we're gonna measure this distance right here. All right, let's get going.
Two. Three. Oh, new record.
All right, Brielle, I'm gonna measure the meters from here to your shoulder. All right, sit up straighter. Okay, now move up your arm. Come on, I don't go all day. Come on, there we go. Okay, all right, get up there. Get down. Oh, holy. Alright, so it goes to the 45 right there, and then the length going from your elbow to the weight. Go ahead and hold it there. That's good. Alright, sit up straighter. Alright, 31. So you gotta remember 45 is there and 31 is here, alright?
Yes!
The cosmos believes in you. Oh yeah. Alright, so we're gonna see what everyone's doing. We're all tired, so let's go check up on everybody. Gotta make sure to be quiet. They're in deep thought right now.
Mass times acceleration equals force. If mass times acceleration equals a force, that means that the velocity has to be meters per second. But if the velocity is meters per second, how is acceleration meters per second squared? I don't understand this. I don't understand this. What is the answer? Oh! Right.
It's not writing! What is happening?
Emily, what are you doing?
I'm trying to write, my pencil won't work. I came up with a great idea.
Emily, you're writing with the eraser. Of course it's not working.
Can we cut that clip? Alright, so the formula for work is force times distance. We know that to find the force equals mass times acceleration. So first we're going to find the acceleration, which is meters per second squared. And in order to find the meters, we're going to measure the distance from Brielle's elbow, from Brielle's shoulder actually, to her hand horizontally, and then from her hand when it's lower to her shoulder vertically. Then we will find, and then in centimeters we found that distance is 54.64 centimeters. When we convert that into meters, it is 0.55 meters. Now, the amount of seconds it took her to do that curl was 15 seconds. So we're going to do the meters over the seconds squared, which will equal actually 0.0024 meters per second squared. And then we're going to times that by the mass of the object she was lifting, which was 1.361 kilograms. Okay, so now we have the force, and now we need to times that by the distance, which we found out earlier, is 0.55. And so the work that she did, when we times those numbers together, is 0.0018 joules.
Brielle and Emily have been wondering why some rich American billionaires here. Well, I have a very exciting announcement for them because I have no idea what to do with my money. Brielle and Emily, I have a very special announcement for you. Are you ready?
I don't know, what could it be?
The International British and American Space Institution, funded by me, are sending you to space.
Okay guys, so we're going to show you what exactly we're doing in space. You might have thought that we're just going up there for kicks and giggles, but actually we're going to perform some experiments up there, and it's going to teach us more about how work is different on the Earth versus in space. So Emily here is going to demonstrate what's going to happen. So we're here in the US and we're gonna this is our rocket,
Our aluminium rocket.
yes, our aluminium rocket, and we're going to blast off, and we're going to be in outer space somewhere up here, and then we're going to be in the Earth's orbit. So we're going to orbit the Earth. Yes, precisely, just like that. And while we're in the Earth, we're actually inside us on gravitational potential energy well. And we'll talk more about that when we're in space.
So Oakley, what do you want for lunch?
A nice juicy hamburger.
What on earth is that?
We're so excited about this.
It's so fun being in zero gravity.
May the mass times acceleration be with you.
Okay, now how about you pull out
Anyways.
your weights? We kind of want to
Okay.
see how work actually works in space rather than on Earth.
So before, when I was doing it on Earth, it was just a little hard for me. So now we're going to see if I can lift this 1.361 kilogram weight with a little bit more ease than I did before. So, oh yeah, this is nice.
Oh my goodness, that is insane.
Maybe I should work out in space more often. Okay, so now we're going to explain the physics behind why it's easier for me to lift this weight on here in space versus on the Earth. So, every time I lift it when I'm on Earth, I have to counteract the acceleration due to gravity from the Earth, and that's 9.8 meters per second squared when we're on the Earth. Now when
So actually, it's really less of a weight and more of a mass that she's lifting.
That's true, Emily. Thank you for mentioning that. So, now that I'm in space, the acceleration due to gravity is a lot less than 9.8 meters per second squared, and so I have to counteract less of the acceleration due to gravity on the Earth, and so now I'm able to lift it with ease.
We are literally floating right now.
We are. And so the Earth has its own gravitational potential energy well. And so what this is it has its own gravitational force, and the farther away you get from this object, in this case the Earth, the less its gravitational potential energy well has an effect on you.
So Brielle, if you wanted your own potential energy well, what would you say to me right now?
I would say that I have to go in the middle of nowhere where there's no stars, no planets, nothing by me for miles and miles and kilometers.
So you basically tell me to get lost.
Yes, get lost.
I see how it is.
And then wait, come back, Emily, come back. And then you could potentially have something really, really small like this, and it would just float around you because you'll have your own gravitational potential energy well.
This is pretty great.
You made it!
Yeah. Oh my gosh, I missed the Earth so much. Hello everyone, and welcome to Fabrics of the Cosmos, episode 100. Spectacular scientific space.
What it is? What is missing? Like, look for me, like some hilarious place. Like, I think it'd be so funny if we just go stop by a porta potty, and be like, "Is Brielle in here?"
I wonder if Brielle's in here. Emily did not find this side.
You gotta be. Oh, I started. Well, I did that out, but you gotta be like fake crying.
She's not anywhere. I can't find her anywhere.
I want to hear a joke. Lighten the mood.
Sure. Okay, so we're all really tired. We decided to take a break. Let's see what everyone else is doing right now. Be quiet. I don't know what she's doing.
Being British accent. Fun, but actually we're gonna perform some experiments up there.